Lecture will begin in 9 minutes. Oh, here we go. I got you. Boom. Oh, well, it's only So I'm so this thing would be first it. Yeah, I agree with that. So I do. Yeah, I don't. So I use so I get that. Then I had to include STD libraries with it, or else get that file. You don't include that with the file. So it's like, wait, last night.
Yeah, I was already one. But I've got like a test of 0 and 1. 5.
Oh, sweet.
I think I'm like,
How do you do it? You literally go to the I have a CD. Okay. Oh god, just so you just went home, did a visual studio project.
I did a business studio one over the but like I did the next one. Like,
oh, really?
Is there a reason for this?
Yeah, so if this is up,
Well, Stephanie found it laying on the floor a few days ago.
yes, I
You know,
forgot
the
to put
old
it
one
in.
got damaged, and we don't know how. We really can't you just slide it to the side or something?
It's not so my students over here.
I mean, that's raise the doors.
It does lower. Yeah, it was my fault for not putting it back on after the lecture. I will remember to do that from now on.
I mean, there was something else you got the camera here and everything. You'd really prefer not to see this. But anyway.
You just have live right now, you also have the other.
Well, yeah, I don't have. Yeah. I don't know if I want to go down that route. I might. Oh, really? So it costs you. Oh, 49.
Yeah, I think
So if you want to say, yeah, right.
This has to go back up.
What?
This has to go back up. It's not coming down. There was a sign on here already.
Oh, yeah?
Yeah, so.
Because the old monitor got damaged. We don't know how. Yeah.
Yeah.
Does it snap in at the bottom or what? Does it,
And it should probably step and forth on the board.
top is lined up with the bottom? Yeah.
Yeah. You will get an email from Stephanie too.
Looking forward to it.
I mean, maybe it would help to lower the table. If this is too high, you can lower the whole table.
Possible. That's difficult to program.
This thing has to be back up here also. And that's a short tether, actually. This is pulled really tight. I don't know what's going on with this. It hardly reaches, actually.
Let me get a back.
So waiting in line. The one at the so they could. Yeah, okay. Basically. No, for real.
I got it. But it's quite tight, actually. I don't know what it connects to, whether it ever gets strained with this thrust rising. I don't know what this is. What's this power to? Is that the monitor? Oh yeah, looks like something.
I wanted, I would like to do that. Wait, where was it? Wait, were they here? Oh, okay. Yeah, I do mind.
There's a DVI. There's a
Monitor's on, but it doesn't look like it's getting.
Oh, the signal cable is missing. Oh, did you take the? Okay. Yeah, no, this is not. You're not taking this off either. I mean, this is.
We have another tether for hooking up your PC.
Where is it?
Is this it, or should be? Where is the other one? It's supposed to be another.
Right, yes.
No, this looks like the one for the.
Oh, that is for the PC.
Oh, right. Yeah, one of my friends said AWS See,
Right. Good.
I don't know if that's a good idea. It's like,
All right, ladies and gentlemen, let's begin. All right. How are you all doing? How many of you have started on homework 3? All right, good. Good. Who hasn't started quite yet? All right. All right. Who has got their at least one platform building? Okay. If you have been confused about the build process, in fact, if you've been confused about kind of any element of the compilation process, we're going to be talking about that a lot today. It's one of those problems that you really want to get solved, so then you can begin working on the more interesting stuff, okay? So, if you look at our schedule, right, we are right in the middle of homework 3. It'll be due on Monday. And so if you haven't gotten started just yet, you will want to begin as soon as possible. There will be kind of a check-in on Friday, okay? And by check-in, I mean the staff will be giving you tips. We'll be trying to get you up to speed, okay? Speed you up, talk about some of the more difficult parts of the project. We have some congratulations in order because I think I've seen a total of 2 100% so far. We've got 2 students in the course I've seen get 100%. I've seen no one get it on all 3 platforms. But it's very, very impressive stuff and very fast builds as well. And so let's go ahead. I think what was it? I think about 7 hours after we launched the homework, 7 hours or so after we launched the homework, the first 100% came in. So that was really cool to see. Well done. Well done. Okay, before we get into that, though, we have a game engine of the day. This is an engine called Pico 8, okay? This is one of the engines you could have chosen on homework 1 and 2. Who did that? Right? Okay, a couple people. Fantastic. It is an engine that, admittedly, I have not used a ton. It is a very unique engine in that, in some ways, you could say it is fairly opinionated, just like RPG Maker. But whereas RPG Maker, right, imposes constraints and gives you a lot of built-in features it really wants you and expects you to use, Pico 8 kind of imposes constraints in some areas, but then gives you a lot more freedom in others, okay? And so this is often referred to as a cozy, colorful, miniature, all-in-one game editor. It is sometimes called a fantasy console. The little tagline here, which is, I don't know, it kind of feels like marketing to me. This really is a game engine that kind of imposes kind of classic-style hardware constraints on a lot of aspects of the engine, okay? Its initial release was in 2015. It was created by Joseph White in Tokyo. There's a really nice talk at the New York University Game Center. An hour-long talk kind of going over Pico 8. And so I encourage you to watch that if you're interested. Interestingly, it's another engine in the kind of RPG Maker style that is actually a premium purchase. So if you make a very popular game with Pico 8, then you're not going to get taxed on that at all. Okay? Now, I think the chance of making a gigantic viral hit on Pico 8 is not super high. And if you do, it's probably going to be from a game that was a prototype on Pico 8, but then moved on to a different engine like Monogame or Unity or something for its final release. And of course, I have to be talking about Celeste. Has anyone heard of this game? Has anyone played this prototype? Okay. It's good stuff, and it has a lot of the spirit of the final game in here in this original. We can see it right here. Right? So 2 buttons, a platformer with an aerial dash, okay? Now, if you haven't seen this game, that might not seem super innovative. When this game came out, aerial dashes were not necessarily as popular as they are now. And it does seem like every indie game seems to have them these days. It was also not nearly as cohesive and well done as it is in this game, in the final game. Right, we've got little strawberries for extra little challenges. How do you get up to it? In this case, hold on. Oh, there we go, like that, right? And so you can see a lot of the kind of core gameplay is here in some fashion, and it was fun here. And so the team knew that it would be way better when they actually invested their time and the resources and money into making it, bringing it to a full release. Okay, so pretty impressive stuff. Another interesting thing about this engine is that you look at this image right here. Okay, see this image? This image right here is a small PNG image, and it is actually the game. Okay, this is an image, a PNG, yes, but inside the image is steganography and a bunch of hidden information that encodes the game's assets and logic and sounds. And so you can actually just save this cartridge to your file system, and that is actually a game, which you can point Pico 8 at, and it will load it up, and it will play a game by ingesting that image, which is pretty cool, isn't it? So you can read a little bit more about that and how they did that in the documentation here. One thing you can see in this GIF is that there are quite a few, well, there aren't quite a few, but there are several modes within Pico 8. There's some built-in utilities dedicated to, for instance, writing code, Lua code, drawing sprites and creating characters and animations, and then kind of a tile map to help you place those animations around a map. All right. Not shown on there, there's also a kind of audio and sound editor as well. And so you can make kind of an early style, classic, NES style game with this approach, and it's pretty interesting. Let's go a couple more things. This display is 128 by 128, so a square resolution, 16 colors, and if you think about it, really, it's kind of like if our two categories, the minimalist engines and the integrated engines, got together and had a baby, right? They have a lot of traits from both. There are a lot of constraints, and you don't get all that much technology given to you, but it does give you some technology, and it expects you to use it, like an integrated engine. So anyway, very interesting stuff. It has a command line, so you need to be used to that and ready to use that in order to launch certain programs, in order to launch your games. Interestingly, it was written in C. So I understand not even C++, which is kind of interesting. It was written in SDL as well, and this might explain why you can get multi-platform versions of the game, of the engine, so easily. And you can also use the web edition, which is how basically you can use Pico 8 for free. All right, and type help. So you can go ahead and you can, editor, right? Code editor, Control Y. Is that, no, Control U? Control V? Yes. Oh, it's escape? Oh, there we go, right? So we're in the editor mode now. We can kind of switch between the tools. You can write Lua. You'll discover that there's some lifecycle functions in there that will, just like an integrated engine, be automatically called. It's a pretty good time. I have not used this for very much, so kudos to you if you use this on Homework 1 and Homework 2. It was a probably interesting challenge, wasn't it? Did you enjoy your time? Yeah? Yeah. During the talk, it is, I believe they say a few times that those constraints, right, are really about allowing you to explore the creative space and not go down all the technical rabbit holes that programmers like us tend to do. You can just focus almost purely on your design and making sure you have a great game design, and then maybe move it on to other engines later if it works out. Okay? Transpilation and compilation has gotten very good. So this code base, apparently for the creators, it's very easy to create web builds. It's very easy to create builds for all the platforms with this code base they've made. Okay? So pretty interesting stuff. It'll be interesting to see if there are any competitors that arise kind of in this kind of niche. I think, let's see, Pico 8. If I recall, the author of Pico 8 was working on something similar, but for 3D and voxel aesthetics. Yeah, Voxatron. Okay. So it'd be really interesting to see what this is fully like. I'm not sure if it's completely out now or if it's still in development, but seems to have the same philosophy, just kind of moved to 3D. So that'd be an interesting one to check out. Okay? All right. The Twitch stream has begun. Hello to everyone watching on Twitch. Congrats again to our first place students who got in. I do think it would be really cool if the autograder told you like what order you came in. So when you get that 100%, it would tell you, hey, congrats, you were student X. Maybe we would only do that for like the first 10 positions, as that's kind of cool. Yes, the assignment, the first 100% came in about 7 hours after the assignment was released. Now note, that does not mean it took 7 hours in total, okay? I'm not sure if the student took breaks or not, but we will, you'd have to ask. One thing that struck out to me immediately is the commit messages are looking a little bit dry these days. These kind of commit messages are totally fine. They'll work, but just be, you're going to find it really nice if you try and add as much detail as you can between commit messages. I know sometimes you just make a tiny change and you resubmit it to see if it builds or see if something works. But if you make, a number of changes, big changes, then please, write up something, write up a description, and you'll thank yourself later if you ever have to go back to a commit to revert, or if you're just trying to understand what you did a few days ago, okay, and what you're going to do next. All right. And there were some better ones. This one's better. I like this one better, not because it's more informative, but because it's funny. And we do read some of these, so we appreciate the detail and the humor, okay? A reminder, tomorrow, Michigan's largest game studio, Stardock, will be here. Not here. They'll be downtown Ann Arbor at IGDA Ann Arbor, our monthly meetup. They will be led by Rayanne Harden, who's going to be speaking on the topic of recruiting, networking, portfolios, and employment in the games industry. So if you are interested in networking, portfolios, getting a job, internships, basically for any company or any industry, not just games, it might have something of value for you, that talk, okay? I think you can also get extra credit, maybe on, is that true? Let me see here. For my other courses, you can get extra credit. Let's see here. Yes, you get 2 points per visit. If you go to IGDA Ann Arbor, if you take a selfie and with one of the speakers, you submit that to Canvas, and you're going to get 2 points, okay, for immersing yourself in the local game dev community. It's generally a pretty good idea. I found a cool documentary on the renderware engine. If you remember, if you were playing video games kind of in the early to mid 2000s, if you're playing, I think, Burnout series, the Sonic series, multi-platform Sonic series, right? Tony Hawk, Persona, right? GTA, then there's a very good chance that you were using the renderware engine. And this is an engine that, I'll be honest with you, it could have been Unreal. It could have been in the driver's seat, one of those engines that we all use and study today. Instead, it is currently gone. It is totally defunct. And a really kind of tragic story, we might get to it a bit later, but they got bought. Anyone know who bought them? Very prolific engine. A lot of multi-platform game releases using renderware in that kind of mid-2000s era. Yes?
Was it EA?
My beloved Electronic Arts, right? They would take good care of it, right? No, it didn't go so well. So as soon as EA purchased the creators of the engine, was it Criterion, I think? The updates stopped coming. The support for third-party users of the engine stopped coming. And it kind of fell apart for them, okay? Big bummer. Anyway, that kind of stuff can happen. Right? Ownership of important technologies can change all the time. And if the wrong owner comes into the picture with the wrong business plan or the wrong incentives or the wrong objectives, that can be the end of that story, okay? Which is in part why open source in general is so important, okay? All right. Anyway, if you get a chance, if you're bored, give that documentary a watch. It's pretty good stuff, okay? Thus far, how is Homework 3 going? And not just is it going okay or badly, like what's the experience of Homework 3 like? Very curious. Yes?
Troubleshooting with a bit of game engine stuff.
Okay, troubleshooting with a bit of game engine stuff. Have you gotten the engine building yet? No? Okay. So we're going to talk a lot about how to get the engine building today. And in a more general sense, the compilation process and how to debug certain issues. I'll be honest with you, like certain challenges are really, really fun and satisfying to tackle. Writing code for your engine, deciding what kind of design decisions you're going to make to keep things performant, but also to keep things elegant, maintainable, expansible. Those are the interesting challenges. You know what is not interesting at all for most people? Trying to get the compiler to stop spitting out these weird, awful-looking errors, okay? It crushes morale. It crushes your momentum. It can just kind of ruin your night if you bang your head against those kind of issues when you really wish you were banging your head against much more interesting satisfying challenges. Okay? So we're going to talk about that today. In fact, that is pretty much the main topic today. All right? Today, we're going to go through some pragmatic ideas relating to the compilation process. And we are going to then program kind of a start to the project together. I'm going to show you how to include GLM. I'm going to point you through some things, and we're going to create our game loop. And I'll just kind of walk you through the process, okay? If you haven't started yet, if you are feeling a bit nervous, where do I begin? We're going to give you that beginning today, okay? All right. We're watching very, very closely homework 3 and all your auto-graded assignments. We are very, very curious to see what that student experience is going to be like. We appreciate your feedback a lot. One really interesting thing, and this connects to game design, and because it connects to game design, it also connects to course design and education, is that very often you can kind of learn just as much about an experience, about anything, not necessarily by listening to students or your users, but by watching what they do, what they try, okay? The questions that they ask, all right? I can ask you if the assignment is going well, but, maybe you say yes, maybe you say no, maybe I ask so you want to tell me yes. But when I see that like 10 different students are trying to compile the Linux build with G++, and I'm looking at your code bases and I'm just, oh God, oh no, oh no, okay. That tells you something, right? That we haven't made it clear that G++ isn't here. This is a Clang++ course, and so you'll be using that, and then we can go improve the documentation. We can improve the autograder hints, okay? We can do stuff like that. So anyway, just kind of an interesting tidbit. You pay attention to what people do and the questions they ask, and you can learn pretty much everything that you need to know, all right? Okay, does anyone have any comments or questions on homework 3 on the course in general? No? All right, good stuff. Oh, yes, question.
No, was the multi-line commit issue fixed?
It should be. Yeah, it should be. The big challenge for me was that by the time I got there last night, like 10 p.m., to update the autograders, we didn't have any recent commits that had multi-line commit messages because the students, when I sent that message out, the announcement out, everyone stopped doing that. So this is to say I think the fix is in, but I haven't been able to test it. So please return to those nice multi-line commit messages, and we're going to see if how that goes, okay? And if it breaks, just don't do that again until I can fix it. All right, Nikhil, what is the discussion topics for Friday?
So on Friday, we're going to talk a bit about some stuff you'll need for the later parts of the assignment, particularly C++ sorting and C++ unordered map and set, and those types of containers. We'll go into homework 4. I'll give you my tips from homework 4, and then we'll give you a tutorial on how to use RapidJSON, which is a library you'll need for homework 4.
Next week is all about extensibility, expressiveness, okay? You have a hard-coded game this week. This week, you're basically game developers. Next week, we genuinely take a step toward becoming engine developers. And in particular, the topic of modding. Because we won't have a full engine, but we're kind of taking our game and exposing things, externalizing assets, maps, actors, all that stuff, visuals, to the point where the game feels moddable. It's kind of a midway point between a hard-coded game product and an engine. The moddable game is sitting right there in between. Okay? Actually, and this is a bit of a spoiler, but so homework 4 actually requires you to hack an indie game. Hack an indie game that is not moddable. You're going to go in, you're going to basically look into its RAM, you're going to find where certain special values are, and you're going to change them. Okay? So if you've never done something like that before, you're basically creating your own cheat codes, right? That's kind of how modding starts. Has anyone, who's played Super Smash Bros. Melee for the GameCube, right? Classic edition. You've seen it? Who's seen it? Okay. That game Someone tell me about the mod support for that game. Okay. What's that like? Okay. How many dollars did Nintendo spend making that game moddable? Anyone know? Okay, out with it. Someone say it.
Zero.
Yes, no, they didn't at all. Right? Nintendo is not the kind of company to support mods in any way. What's really interesting, though, is that Nintendo made a game that does not have any built-in support for mods. That did not stop people on the internet from basically reverse engineering the game's assembly, and building kind of some platforms, right? Figuring out where certain things are and tend to be in memory, and then basically building a framework to let other people make mods more easily. There are a ton of mods for the original Smash Brothers. You can use them with the Dolphin emulator, and it's cool. Like HD widescreen support, new characters, new moves, new audio stages. Yeah, it's crazy. This is also to say, pretty much no matter what code you write, when the user gets their hands on it, it is truly theirs. Okay? And a lot of people don't realize that. In fact, a lot of players don't realize the power they actually truly have over the things running on their machine. Okay? You will next week. So please look forward to that. All right? Okay. Okay. So I immediately knew we had a little bit of a problem when on Monday I kind of walked around during office hours. And I think during that 2-hour block, I think we had one student in here manage to get their building, okay? Get their project building on the autograder and doing a good job. I don't think they got any points, though. But they got it building, and they got a little bit of help from me to make that happen. So the topic of how to use an IDE, how to get a C++ build process going, and I think most importantly, how to understand what's going wrong when it fails, is a really big deal, okay? It's not maybe the most exciting topic, but I'll tell you, once you know how to quickly resolve those issues, it feels very, very good, okay? You feel very powerful. I remember at Electronic Arts, there was like one person on our small kind of mobile central technologies team that was extremely talented at solving compiler issues, dependency issues, linker issues, stuff like that. And everyone would be grabbing that person, right, and being very friendly to them to get them to come over and solve their problems when all those horrible compiler errors showed up and they couldn't figure them out. All right? And so the compilation process, the IDE process, can be a pretty spooky one, okay? You look up here, you see a lot of scary things, all right? Endless amounts of UI you have to kind of explore. It's like a maze, right? Really nasty error messages, right, that aren't very good at explaining what's going wrong, okay? I mean, look at this rating for Xcode. Did anyone else chuckle when they go on Apple's own store to see that their own, like, their main development tool is just, oh, this thing's crappy, right? And then we kind of got Clang up here, which is just super, super simple and nice. I think that's maybe why a lot of people love Linux and Unix, and it's not much clutter, okay? But there are reasons that you want to get very good at using Studio, right? Visual Studio, Xcode, right? Make these IDEs, these compilers, they are incredible when you can get them onto your side, okay? I'm talking about features like syntax highlighting, okay? Right? Being able to very clearly see variables from functions, from classes, right? I'm talking about code completion, right? And this is absolutely incredible. Basically, in my other courses, and in this course too, if you don't have code completion, your learning rate, your learning speed is probably going to be half of what it could be. Okay? When you are new to a technical ecosystem like Unity, how do you know what functions are available to you on a data type? How do you know what variables exist? How do you know what data structures exist? Unless you are reading the documentation page by page and perhaps getting pretty bored doing so. right? Code completion offers you a lot of freedom. It unleashes you. You can begin playing around, experimenting, and if that's the way that you learn fastest, it's really important, okay? Warnings. So on Piazza last night, I think, I saw there was an interaction. This is with Jonah. So Jonah, what happened?
I made a commit and everything stopped working. And I was looking at like discrepancy in the autograder, like what I had, and then you just told me to go back a couple commits and see if everything was good. I went back, saw it was good, and then looked at the diff and like kind of realized what was actually going on.
So what was going on? What was the problem?
I had undefined behavior in my code, so
Yeah.
I was returning something.
Yep.
And locally, it was returning true, which was great, what I wanted.
Yep.
On the autograder, it was
There's a returning false on the autograder. So undefined behavior, right? If you do something a bit strange, but the compiler lets it, be okay. For instance, right, have a function with a return type, but then have one branch that returns nothing. That could blow you up. That could cause inconsistencies between the autograder and your home edition. You won't understand what's not working on the autograder. These are issues that can be really easy to miss, to skip, to not notice. If you have things like warnings set up, you will get, right, a little announcement that, hey, you're doing something very risky right now. You really should consider doing X, okay? And that can save you a ton of time, all right? And of course, it can also point out things early, like, hey, this isn't going to compile. You don't need to go through the process of doing a lengthy build because the syntax, the little red underline, will tell you, hey, you're doing something that doesn't make sense here. It's not going to compile. You should fix this first, okay? And so just a massive amount of time can be saved, and this is before we get to topics that are relatively new, like embedded AI assistance, right? Basically, what if we could get GPT into our Visual Studio, into our Xcode, our editor, and kind of accelerate the way we're programming, okay? A lot of programming is really clever and satisfying, but there's plenty of programming that's a little bit tedious, all right? And the AI can often help us really speed that up, okay? Other things, embedded version control, right? The features just don't seem to really end when it comes to IDEs, compilers, and all that stuff. That's maybe part of the problem. But if you can make use of it and you can make sense of it, then it's going to really benefit you to do so. Oh, by the way, if any of you had any plans to one day work on a AAA game, they're not making AAA games in Make, okay? It's very sad. They're not doing it. I don't know any company that is, though maybe they're using it for some tools. So you will, as a pragmatic matter, be forced to learn these IDEs at some point if you want to do this kind of business, all right? And there are a lot of really fantastic reasons to love these IDEs, get good at them, but my goodness, these things can cause some problems as well, okay? Number one, and you'll feel this probably if you're in Visual Studio or Xcode, probably especially Xcode, but there is so much UI in these programs. They are very big programs. They got a lot going on. There's a lot that can get messed up. There's a lot of things that you need to remember that are very easy to forget, okay? How many of you who have tried to get building, how many of you have already basically failed a build because you forgot to switch to the C++ 17 standard, right? Well, it's more than just a few of you, okay? I was watching. Right, there's just so many things that you can mess up or forget to do. When you have an issue, like a linker issue, it can often come out in the form of a really kind of hard to parse, hard to understand error, where you don't really even know where to start, okay? You don't know whether you're just wholesale missing a dependency or whether you have a typo someplace, right? Even something being uppercase when it should have been lowercase could be enough to wreck your build process in a way that you're not going to understand, so you can't recover from, okay? Crashes, slowness is also a big thing. On my home desktop, where I do most of my development, my C drive has about 3 gigabytes left out of like 500 gigs at any given moment. And over time, the longer I keep Visual Studio open, the closer I get to going down to 0 megabytes remaining in my space. And so I have to kill the Visual Studio. That frees up the 3 gigs, and then I've got another half an hour or so, okay, before it has eaten up the rest of my hard disk space, okay? It's a pretty nasty existence sometimes. But all these things, right, can drive you to just saying, hey, you know what, I'm just going to go minimalistic. I'm going to use Vim, all right? Why not? I'm going to use Vim, I'm going to use Make. These are really great tools, actually, and you can customize them to your liking. You can make them very powerful, and quite a few people do. But we really do want to conquer these demons, okay? We want to get those benefits, and we can. You can get good at this stuff, okay? I wouldn't have believed it a year ago or so, but like basically designing the projects and building the engine, the staff solution, helping Nikhil with some compile issues, you do start to get good at this stuff, okay? Or at least faster, better, okay? So don't give up hope, right? Yeah, and this can feel really good sometimes. Okay. So one kind of philosophical thing I want to run by you is this idea that not all challenges are made equal. I kind of talked about it a little bit earlier, but imagine the challenge of lifting weights, right? The challenge, right, of bulking up, of getting to the gym, okay? The kind of challenge that you probably would enjoy there, that's probably beneficial for you, is the challenge of getting a PB, personal best, okay? You get in there, you kind of size up the weights, and you're like, oh man, that's 20 pounds heavier than I've ever done, right? And you go down, you don't quite know if you're going to make it, right? And it's satisfying, and maybe you don't make it, okay? But maybe you do. And no matter what happens, even the attempt is probably going to be beneficial for you, right? You learn kind of, okay, no, I got to go a little bit lighter. Maybe you get slightly better with form, right, as you practice those reps, okay? And so it's the right kind of challenge. It's the kind of challenge you embark on to learn. And by engaging with it, you grow. You know what's not such a great challenge? Can anyone think of a crappy kind of challenge when dealing with weightlifting? Yeah. Oh, injury, that really stinks, yeah. Dealing with injury is really not satisfying at all. It's just a downer, pretty much. What else? This is one that's bitten me a few times. I'll drive to the gym, but oops, I forgot my my gym pass, right? So the challenge here then is find the gym pass you swore was left on the table, but it's not there anymore, okay? Nothing good will come out of you like engaging with this challenge. It is purely a burn of time. Your morale will sink. You'll gain nothing, okay? It's garbage. You want to avoid this kind of problem as much as you can, okay? What about the challenge of playing a video game? In particular, reaching a new multiplayer rank in your favorite game, right? You're playing StarCraft, you're playing Fortnite, you're playing whatever game you love, right? You're enjoying the experience. It's relaxing for you. You're socializing, building your relationships with others, right? You're getting better at the game. You're playing Fortnite. You're getting better at it. What's a crappy kind of challenge you could find in this space?
Stop your game from crashing.
Stop your game from crashing all the time, okay? And yeah, right? When your game is unstable, you're not really learning. There's not a whole lot you can do about this, right? You just have to kind of run the game again, launch it again, cross your fingers, pray, whatever you want to do to make yourself feel better. Because when you're just trying to get your game to remain stable and not crash, you're basically just burning time. Okay? It's not a good kind of challenge. To bring this back to this course, okay, the good kind of challenge in this course is typically going to come in the form of how can I find an elegant way and performant way to add a new feature into our engine? Or how can I improve our engine's performance without compromising the clarity of our code and without introducing any bugs, okay? Very interesting challenges. I think you're going to like those kinds of challenges a lot. In fact, I can't remember who it was, but like You remember the Google, like the Google Docs have this little chat bubble in the right side that no one ever uses? I got a message at like 2 a.m. last night from someone saying this assignment was really fun. And I'm not, hopefully it's fun for all of you, that student was enjoying it. And hopefully it's useful. But anyway, the kind of challenge we do not want you spending and burning a lot of time on in this course is the challenge of, for instance, trying to get Lua to just compile and link. Okay? Like, Nikhil, how much time do you think you burned at the beginning of homework 7?
I think about 5 hours.
5 hours. Whoa.
Yeah. I'm going to create a guide to make sure you guys don't go through that.
Yeah. The reason Nikhil is going through this is so that you hopefully won't have to. All right? We got all the strats for you because we are getting wrecked in your stead. Okay? But I hope you get it, right? There's certain problems we want you really engaging with, problems we think you're really going to enjoy, and then there are problems that are just garbage, all right? Now, there is some satisfaction to learning how to integrate and link things properly and to inform your IDEs, configure them properly. I don't think a lot of you are going to really enjoy this, but it is important we figure out how to do it well so we can get past this crappy challenge into the really interesting stuff, okay? We got to do it soon. All right. So anyway, yes. Over here, our challenges increase our knowledge. They're impactful when we solve them. Every attempt is worthwhile, okay? Even if they don't succeed. Over here, it's just garbage, right? There's no knowledge we're gaining. There's less impact. We're really wasting our time. So we want to get rid of those if we can, okay? We're going to spend more of our time on the interesting stuff. An interesting way to think about this is that the more guidance you receive on a topic in this course, the less we think of that challenge, right? The less interested we are in you burning time on it, okay? So you'll find, for instance, that there are a lot of guides on your assignment specs to try and help you somewhat quickly get your code building on the autograder, okay? So please make use of those. If you haven't looked at these before, it's a little bit messy right now. It's the first debut semester of the course. But there's a guide that will take you through how the autograder works and give you some tips on how to submit and how to get your engine to build as well, in addition to some troubleshooting tips as well. Now we also, and this is slightly redundant but not entirely, we also have dedicated guides for Visual Studio, showing you the UI, what to click, stuff like that. And we have it for Xcode. And I made, this one's going to be really important, I think. And we have one that was a little baby one that I made for Make. Because, I couldn't really think of all that many things we really need from Make. The Make file for the staff solution is it's tiny, right? There's not a whole lot going on in there, okay? It's not a whole lot you need to go on, okay? But as you add more and more dependencies, that Make file will grow. But we don't have that many dependencies in this course. We have some. Anyway, it can be a really good time. And learning how to navigate this UI, set things up properly is what those guides are for. So please do use them, okay? All of these IDEs, all of these build systems can feel very unique, but in the same way that every game engine looks kind of different, but under the hood, not so much, right? Once you get using them, they all kind of philosophically have a ton of parallels, right? Your IDEs, your compilers, your build systems are the same way, okay? And here's the real takeaway from this talk. The other stuff is just fluff, okay? Here's the real takeaway from the talk. When you get into an IDE or a C++ build environment, there are basically 4 questions that you must answer for your IDE, okay? And if you answer them, you're probably going to build just fine. If you forget to answer one or you mess up an answer, you're going to get weird errors, and you'll have to figure out which question you messed up. Here are the questions. The very first answer you need to provide is, where should the compiler or the IDE look for headers? Okay, include files, your .h stuff, okay, or .hpp, right? In Visual Studio, what you do here is you right-click on the game engine kind of project name in the right-hand Solution Explorer, and you go down to Properties, your project properties. You'll find that your project properties is actually a file on your disk that has basically a bunch of XML with a bunch of these values kind of defined. And so what you'll find here, if you click on Visual C++ directories, is you'll find the include directories, okay? This include directory right here is basically going to list out all the directories where the IDE or compiler should look for headers, okay? So I'm going to actually show you this when we import GLM in just a bit. But if your include statements are showing that little red squigglies, if you can't compile at all because of a bunch of GLM stuff, IVEC, we don't know what that means. It's a missing identifier. This is probably what's going wrong. Okay. On make, there's kind of a really weird syntax for this, and it really just looked very strange to me when I first saw it. With make, and actually with Clang, what you do to tell the compiler which directories to look in is you do -I, and then you can just kind of list out the path that you want the compiler to look in. Okay, I usually put a dot there, which is just to say wherever we are compiling this, make sure that you look down this folder path, and in this folder, you'll find all the headers, okay? One really big thing to note is that you can almost always tell the compiler or IDE where, like, multiple directories to look in, okay? So one kind of like desperate maneuver you can try is if it's just not finding the headers, you can just start adding more and more of these folder paths until eventually the squiggly goes away, and then hopefully you can learn, oh, it wanted this, okay? This is how this works. And that can be helpful. In Xcode, if you go to the build settings, which is usually kind of a bar at the top, you'll see build settings there. You'll find a ton of settings. If you do a little search in the panel, you can find these right here. You can find framework search paths, header search paths, library search paths, okay? And basically, you'll do the same thing. You will go in there and you will write the relative kind of path of the folder or folders that you want Xcode to look in for your headers, okay? One really big deal is you do not want to use absolute paths when you specify these directories to look in. Why? Because if you give us a huge path that includes, for instance, your unique name in it, your username, you're going to have a bad time, all right? And it's because when it goes onto the autograder, that path is not going to exist. Your user folder will not exist, and everything will break. So typically what you do is that the IDEs will provide you with this kind of relative, shortcut, a little tool, right? You specify this, it's a little variable, and it will evaluate to your current directory, wherever you're doing the build or wherever your project is, okay? So you can use these. One really sad thing is that I think on Visual Studio, it's money sign, right? And then open and close, and in the middle, project dir with no space. On Xcode, I think it has to be this instead, like all caps and then underscore between project and dir. And so if you forget this or switch them up, you're going to be sad. So just look over these slides if things aren't going well for you, and hopefully you'll get things building soon enough, okay? Once you have told your IDE where to look for headers, that doesn't really tell them which ones to use or include. And the way you tell what you want to include or not is actually in your source code, okay? The preprocessor is going to run down your files, and when it sees this hashtag, okay, and include, it's going to go in and try and find this stuff, all right? It's going to look wherever you told it to look for these file paths. All right, and if it can find them, awesome. It's going to resolve. It's all good, okay? And if you still have little squigglies there, then something's gone wrong, okay? Okay, a little question, little trivia. What's the difference between the brackets? Are these brackets or braces or carrots? What are they called? These definitely are square brackets. Angle brackets?
Angular brackets.
Okay, gotcha. What's the difference between using include and angle brackets and include and quotation? Anyone know or remember?
I think one's for like an actual standard library and one for like an actual like your own header file or like your own file in the directory.
Yes, kind of. So basically, like culturally, you are meant to use the double quotation version for your local dependencies. Okay, so a local H file, that's where you typically see it. And if you are using kind of a global static library or a static header, then you will, or a global header, you will use the caret brackets. Okay, and that basically tells it to not look locally for vector. Look in all the global folders for vector. However, apparently, and I read this last night, apparently, if you use the double quote method and it fails to find what you were specifying, it will actually then literally do what the caret bracket does. And so, actually, it's a little bit redundant. Okay, you could use double quotes for everything. So, there you go. It is customary, okay? It's a bit of a standard. You use the angle brackets to denote like a global library system-wide and a global dependency system-wide, and the quotations for stuff that you wrote, right? Custom stuff that you're responsible for. Okay, that should take care of our includes and our headers, all right? Not that crazy. The third question that you deal with is the question of where should I look for the libraries, the static libraries. For this, it's pretty much the same process as telling your IDE or compiler where to look for headers. Okay, you will find a library directories path right below the include directories in Visual Studio. Okay, in Make, you don't use a capital I, you use a capital L. All right. Same thing. You just provide the directories where those libraries are chilling, and you're good. Okay. In Xcode, it's the exact same thing, right? So telling the IDE or the compiler where to look for stuff is it's pretty samey. Okay, it's not that crazy. The final thing, and this is a little bit weird. You don't have to deal with this on this homework, but the final thing is telling your libraries, your compiler, where or what libraries to actually link, okay? So you've told it where to look for libraries. Now we have to tell it which of those libraries we actually want to use. Not all of them, so tell us which ones you want, okay? And in Visual Studio, what you'll do is you'll go actually down from the Visual C++ directories. You go to Linker, open that up. In Input, you'll find the additional dependencies little area right here. You can go in there and you can actually type out the name of the files that you want to use. All right? And then it will actually try and link against those if they can be found. Okay? In the Make, what you can do is you actually use, not capital I, not capital L flag, but use a lowercase L flag. And then right after that lowercase L, you put the name of the library that you want. So in homework 7, you're going to have something like this, right? -L Lua 5.4. And on homework 5, you're going to be using these, right? -L STL2, -L STL2 underscore image. And if those libraries can be found, you will link, okay? What about Mac? Okay, this is a bit of a mess, all right? So on Mac, your static libraries are going to kind of come in the form of .framework files. You'll discover pretty quickly, I believe, that these .framework files are actually folders, okay? And they've got a kind of a weird internal structure that has some versioning stuff going on. It's kind of funky, okay? But you will navigate through the Xcode UI. You'll click on your project. You'll then go to build phases, and you'll have to add your libraries right here, okay? You'll have to add each one. You'll have to do the same thing by going not to build phases, but to general, where you will want to add your libraries, your frameworks here as well, okay? Every time you clone your, you push your frameworks into the cloud, into Git, and then clone to another machine, all of those are going to break, So you have to do that every single time, okay? Yeah, you have to re-download from GitHub, put them back into Xcode, fix your project up. It's a huge pain. Okay, so I wrote a script for you to just run, and it fixes everything immediately. So what happens is when your frameworks stop working, and I'll have to remind you of this when we get to, what's our first linking? Is that homework 5?
Yeah, homework 5.
Okay. When we get to homework 5 in a couple weeks, like 2 weeks, I'm going to remind you of the script. And when everything goes wrong with your frameworks on Mac, you just run the script in the project directory. You're going to be good, okay? Basically, if you're curious what the script does, I think we can look at it. Yep. Okay. It says... All right, so what does it do here? It is kind of a bash function, and if I recall, it basically does a code sign operation. Apple has some weird security stuff going on, and when you upload frameworks to the cloud and then re-download them, for whatever reason, their signatures get messed up, and suddenly they won't run your frameworks or compile against them because they're not signed properly. You can force them to be re-signed by running the script or just running this code that you'll find in there, okay? And, yeah, it's good stuff, okay? All right, and then once you've solved those 4 problems, for most of our assignments, you're going to be good. Now, in a future assignment, you'll have to worry not just about static libraries, but also dynamic libraries. These are the libraries that are basically DLLs. They'll probably literally be .dll. And those are libraries that actually get loaded up after you run the program. So the compilation will finish, okay? Right? So great. Everything's working. The link will finish. Oh, fantastic, right? No undefined symbols. This is great. And then it's going to start to launch. All right, let's go. And then an immediate crash because it couldn't find a DLL, okay? And what you'll have to do is actually really cool. It's called a post-build event. And in your IDEs, usually what you can do is you can say, hey, after you're done building, but before you run the program, copy these DLLs into the build folder where your program's actually going to execute from, okay? And that will that'll get the job done, all right? In Xcode, you might have to do something called configure the R path, which I think stands for runtime path, where it will kind of look for those runtime dynamic libraries when they try and get loaded, okay? So anyway, there's just a lot of stuff that can go wrong here, but really, no matter what environment you're in, it's those 4 questions, okay? Tell me where the headers are at and tell me which ones you want. Tell me where the libraries are at and tell me which libraries you actually want, okay? A single typo will mess you up bad, okay? So be careful. And if you do make a mistake, chances are you're going to see one of 2 types of issues, right, that are kind of telling. You'll see a compiler issue or you'll see a linker issue. On the left, you can see that we've got these kind of errors here, right? We've got an E error and we've got a C error. C, I have to imagine that stands for compiler. I don't know, though. And it will say things like, hey, this identifier, I don't know what it is, right? It's not around here, right? We can't find it, right? These kind of errors occur really early in the build process, right? They'll just jump at you right away. Usually the Visual Studio or the Xcode with the little red squiggly can point them out to you before you even try and run into them, okay? Linker errors, right, tend to be the scarier ones that are harder to understand and read, okay? They typically involve external symbols, unresolved symbols. And if you ever see like LNK, right, clearly stands for link or linker, okay, then you're dealing with a linker issue. This tends to happen after the compilation is complete. You've created all of your .o files, we put them all together, link them up, and then we're still missing some definitions, okay? Maybe we declared a function, right, game loop, but we forgot to actually write the body of that function, so there's no definition anywhere, right? We can compile everything, but then we're in big trouble, okay? And this occurs later in the process, so that's a hint. And of course, yeah, just reading the details will give you a hint that it's a linker error. To fix these 2, right, you need to go back to your questions, all right? If you know it's a compiler issue, you're probably dealing with headers. right? You need to go in and adjust your IDE's header or include directories and double check some stuff, okay, until those red squigglies go away. You need to potentially tell it which headers to include. So get more include statements in there, or go in and make sure that they're working appropriately. Sometimes if you have too many, you can get in trouble, right? Like what Nikhil and I had the other day. We accidentally included an internal header file for Lua that you were not meant to do, and it blew us up. Blew us up for a while, okay? By the way, this is another reason that version control is so important, right? You can be making some really tiny, innocent-feeling code changes when all of a sudden everything falls apart. And if you've recently made a commit, even if these small code changes look totally innocent, you can work backward and say, oh my God, this include statement looks fine, but actually it's ruining everything. If you have added thousands of changes since the previous commit, though, you're in big trouble, okay? The list of suspects is a mile long, and it's going to be very painful for you to figure that out, okay? You bring it to office hours, I'm just gonna be sad, okay? I may or may not be able to help you. As your code bases get bigger, it's going to become a bit scary for the staff to try and dive into those big code bases to help you, okay? So please, version control, and that's gonna save you. If you're having linker issues, if your issue is over here somewhere, there's a very good chance it's just to deal with your library configs, right? So is my IDE, my compiler, looking in the right place to find my library? And am I actually specifying that I should use the library, right? It's very common to set the library directories successfully, but then, I forgot to actually tell it to use the library, okay? You gotta remind it to use the right library, okay? All right, and the biggest part, again, right, is you never want to give up on this stuff. It will get easier, and as it does get easier, your fun, your satisfaction in this course will go flying upward, okay? I promise you, it's really fun writing code for a game engine. It's not fun getting your dependencies imported, right? You're probably going to have a couple nights maybe looking like this as you just try and get the darn thing building, and it's really frustrating, right? And that's been me a number of nights, okay? Not last night, because last night was about making this lecture. Yeah, and then you'll be going like this, okay? You're going to be feeling good as soon as that thing finally builds and you know you're ready. On to the next stage, finally, okay? Satisfaction. It gets easier. Soon you're going to be that cool teammate that can solve all the crazy compiler issues. That will make you a very valuable person, no matter what team you end up on, no matter what grad program you end up at. It's going to be good stuff, okay? And also a huge one is once you get really good at integrating third-party dependencies, there are a lot of awesome dependencies out there, okay? Has anyone ever tried to make their own fun hobby C++ project, but then you just couldn't figure out how to get something building? It's like, oh, there's this awesome library, but I import it and it's just not working, and the tutorial is so boring, and I don't know why it's doing these things, and the tutorial doesn't even work because it's out of date. I'm using Visual Studio 2019, but it really wants 2017, and so is that the reason? It's just, and you give up, okay? I'll tell you, since I've prepared this class, suddenly it's actually pretty easy for me to bring almost any dependency in now. So I'm scouring the internet for cool, weird stuff, which is very, very exciting. Anyway, you can go and make really cool projects once you're good at bringing in third-party external stuff. So look forward to that, okay? All right. So does anyone have any questions before we do some programming ourselves? No? All right. Good. Very good. Okay. So let's go ahead and get to it. What I want to do here, and I really wanted to do this on Monday, but part of being a debut course, that's kind of hard to tell how long things take. That quiz took more time than I thought it would. So let's go ahead and get to it now, all right? So we've got Visual Studio here, and again, this is the platform that we tend to develop on as a staff. That does not mean what we show you isn't applicable to Xcode, but there are going to be some UI differences that you'll have to keep in mind, okay? And at some point, you'll all have to set up a Visual Studio project for the autograder at any point, okay? At any rate. So what you can do is you open up something like Visual Studio 2022. You go to create a new project. There are going to be a lot of templates in here, and depending on how much you've installed, there might be a ton or there might be fewer. But what you're probably looking for, I always like to just kind of go and look for the empty project, okay? Start from scratch with C++, no starting files, okay? This is from scratch. It's pretty exciting. I'm going to call this my game engine demo, okay? I kind of like to put my solution and project in the same directory. I don't know, it just kind of keeps things kind of clean. Everything to deal with this project is just kind of going right into this folder, okay? Which is kind of nice, kind of like that. All right, well, here we are. That's it, okay? There's nothing here, right? If you are wondering where do you begin, a good place to do so is to probably, first of all, go and set us to release mode. Okay, release mode is going to make your code faster. It's also how the autograder is going to run your code. Debug mode is actually going to be, I think the debugging tools are a little bit more consistent in debug mode.
Yeah,
Like,
because
yeah.
release mode optimizes out a lot of your code.
Yeah, in my experience, release mode tools are still pretty good, and they tend to work relatively well. But you switch that, okay? And now what we're going to do is we're going to go to Game Engine Demo. We're going to right-click on that project. There's this big Add button midway down. We're going to add a new item, and we got an option to choose what item that's going to be. I'm just going to call it main.cpp, okay? The first thing you should always do, right, is write that hello world message. So we're going to grab IOStream, int main, and let's go ahead and write a quick message, std cout. Let's go hello game engines. It was funny seeing these hello world messages making it to the autograder and just seeing the instant fail on all the test cases because of the fun debug messages. Anyway, one interesting thing is we could do, I think, using namespace std, okay? We could put this here and then get rid of our std symbols, can't we? Something like that, right? Okay, I know a lot of you like to do that. What's one risk of doing that? Anyone know? Yes?
You have multiple libraries.
Yeah, like symbol clashes, okay? So what happens is when you say using namespace std, basically all the tokens from the std namespace are going to get dumped in to your scope. And if you have other libraries, for instance, if you have a library that's like mylib cout, that's going to be a big problem, okay? And it's going to potentially break. You can get name clashes and all that stuff. So in most professional code I've seen, that tends to not get used very much. It's a little bit annoying, but we tend to see a lot of this, okay? A lot of std : okay? All right, this is saying in the namespace, in the std namespace, that is the cout that we want, okay? Let's go ahead and let's run our code and make sure it compiles and we get hello game engines, all right? There are a couple things that we want to do before we really get into it, though. We want to go and make sure we're using C++ 17. And if you don't switch it to C++ 17, then the map helper.h actually won't compile because it's using some features from C++ 17. We can go into our properties, just like I showed you earlier. I think we go to C++ and C, we go to language, and then we get the C++ language standard, which we can change. The default is 14. I assume new version of Visual Studios will probably bump it up to 17 and then 20. Okay, but we'll make that change right there. And then we should probably, ask what we want to do here, right? We're trying to make a game. All right, and games are kind of inherently looping structures. They're not just these quick calculations that process and then they end in a single frame, right? A game is kind of a turn-based thing where we're going to do some computation. We might render some stuff to the screen, but then we are going to get user input. All right, we're going to get some input from the user, give them some options, and then adjust the game based on that. So what we should probably do is we should probably create a loop, okay? We could create an infinite loop if you want to, right? This is pretty spooky, right? A lot of people maybe feel a bit uncomfortable with that infinite while loop in C++, freeze the entire program. So you'll often see something like bool running, okay, or is running. And you'll set that to true, and then within the loop, we'll make it possible somehow to make it false, okay, to break us out. Within that loop, we tend to like to go in this order, right? First thing you do is get input from the user. What did the user press this frame? What did they enter this frame? Then we update the state of the game based on that input, and then we render at the end of the frame. Once we're done with everything, we present that frame, right? It's coming out of the oven, and then we can start on the next frame after we presented it to the user, okay? So what we might want to do is we can use cin, right? I'm going to go ahead and put this into a string. Let's call this user input. And the syntax here, I always forget it. stdcin, is it like this?
Yeah.
Yeah. So we can collect some information from the user. We can actually just echo it just to make sure it's working. User, okay. User input. All right. And then, we update whatever that's going to look like, update the game state. And then we can render the game state. Okay? Let's go ahead and just make sure this is going to compile real quick. In general, I really recommend that iterative approach, that 494 style approach. Let's see here. We didn't actually give a prompt to the user. Okay? It is working, right? It's echoing what we put in, but we should probably give a prompt to the user. Let's go stdcout. Please enter E or W to move. Let's also, let me see here. Yeah, actually, that's fine. Okay. And then new line. All right, so we're going to get a prompt now. Actually, let's go to move or quit to quit. Okay. All right. This is our input. This is going to be update. And this is going to be render. Okay. You can imagine right now that we want to walk around in this world. Okay. And so currently we'll just go ahead and walk around on the number line. We can go ahead and we can save a little bit of state. Int, let's go player position, and you start off on 0. And let's say when we go to update, hey, if user input is equal to E, then what we want to do is we want to go ahead and move up the number line, okay? Move east on the screen, all right? Otherwise, if user input is equal to W, let's get a string here, string comparison. Then what we'll do is we'll go player position minus minus, okay? We then have that final command. If the user input is equal to quit, then we'll just go ahead and set that is running variable to false, okay? And that should break us out of the loop after we've rendered one final time, all right? What does that render look like? In your homework 3, you're actually going to create a kind of a cute little mini camera that will follow the player around and show you what's around you as you move around. Here, I'm literally just going to say what position you're on, okay? Let's see. You are at position, okay, and then player position. All right. Okay. Let's go ahead and give it a play and see if our commands work, okay? We get the prompt. Please enter E or W to move or quit to quit. Let's go E, okay, we're at position 1. E again, W, 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 going negative, east, back to 1, and then quit, and it ends, okay? And so we kind of have a really simple, super basic game loop here. Now, we're not really making any decisions yet, right? That's where the game design comes in, trying to make each decision, each command as interesting and consequential in the short, medium, and long term as possible, all right? But for now, we do have a basic game loop going and a basic input collection step, a basic update step for the game state, and then rendering that game state. Now, you might eventually want to organize this a little bit better, right? Because you might say, well, these seem to fit really well into functions, right? And we could do that, but I want to go a little bit further. What I'd like to do here is I would like to actually create ourselves an engine class, okay? I want to create a class in C++. The main file is literally just going to be where our main function is, and it's going to be where we kind of go into the game loop, okay? So let's go ahead. If we want to add a new class, we can create some new files. We can do all of that by hand. I don't really want to do that, though. So we're going to use the power of our IDE here. And I'm going to right-click on the name of my project, go to Add. Instead of going New Item, I'm going to go straight for Class. I want a new C++ class. I'm going to name it Engine. Okay, you'll see that it kind of pre-populates the engine.h and the engine.cpp file, the declaration file and the definition file, basically the header file, the implementation file. And I'm going to click OK, and it's going to create a few files for us. Okay, so we've got our class here, class engine, and it is not super full. It doesn't really have anything in it. And we also have our source file here, our implementation file, which basically doesn't have anything in it either. It's just including that header file, okay? Now, you see this pragma once. Nikhil, have you been using pragma once?
Yes.
Okay, has it been working okay?
Yes.
Okay, so as far as I understand it, so pragma once is really nice. It is an example of an include guard that is going to try and get you away from some common errors that can happen when you accidentally include multiple headers, and that causes multiple definitions of objects, and then you just blow up, okay, and you don't compile. It's really nice because it's a one-liner, but apparently this is like non-standard. This is actually like not defined in any standard. It's just something that most compilers will give you, okay, will do for you. So what I actually like to do is the kind of the classic approach that is standardized and should work everywhere. And it's to do this. If not defined, if ndef, and then engine h, you can make this whatever you want, but it's typically the file name underscore h, right? Then define engine h, and then ndif at the bottom. Oop. Right? Right, this is going to be a very classic kind of include guard that you'll see quite often. And what this is basically doing is the first time that the preprocessor includes this header file, this symbol, this variable won't be set. Okay, it's not going to exist, which means that we will enter into this if statement. We'll come down here and we will actually define that variable, and then we'll get all this stuff, okay? The next time that someone tries to include this file, this symbol now does exist, right? So we will fail this if check, skip to endif, and that kind of protects us from including this header file multiple times, okay? All right, so we've got this engine here. It's time to think up some functions that might be useful. I'm going to write public right here. I like to keep public stuff at the top, and private stuff can come down here, all right? And what we're going to do is we're going to have a very simple game loop function, okay? We might also say, you know, I want a function for rendering or maybe input, okay? So let's do the input function. Let's then do the update function. Let's have one of those, okay? And then let's do the render function, okay? Now you're going to see here that the IDE turns our little function names green, okay? And you can usually just highlight over to get some feel for what it's complaining about, okay? So there's no function definition for the game loop function that we're describing here. This is a declaration file. This is not where the definitions go, but we don't have any definitions. You know where definitions go? They're supposed to go in engine.cpp, all right? This is where we actually write the code, engine.cpp. What I really love to do is when I see this, I'll write the functions that I want, and then I'll right-click, go to Quick Actions and Refactoring, and say, hey, create that for me, won't you? Boom, and it's right there. Okay, and I can just start typing. It's going to have the perfect signature. It's going to be no problem. You don't have to worry about mistyping something or forgetting to put the little scope on here, okay? By the way, this is basically saying, hey, it's a function of return type void. It's the game loop function that is part of the engine class, okay? If you omit this, it's going to be real confused, okay? You're basically just, you got a game loop function hanging out. It's not this game loop function, though, right? So you need that scope operator on there. Okay, we can do this for basically every single function here. Right-click. Oh, it's getting in my way. Okay, right-click. Good, that's done. And then let's go right-click, and that one's done. And then right-click, and that one's done as well. I don't generally trust myself to get these declarations right. I often have a typo. I forget something. So I try and make the IDE do the job whenever I can, because the IDE probably won't mess this up. Though I actually have seen it mess up, especially when heavy, weird templating gets involved, okay? Which we might talk about a bit later in the course. Anyway, we now have all this code that we can mess with and kind of bring down if we want to, okay? I'm going to get rid of this little user debugging code. Let's go ahead and bring this input-related code into our input function, okay? Let's go ahead and let's bring the update code into our update function, okay? Okay. And let's go and bring the rendering code into our render function. All right. So now we've actually, we got a little bit of a problem. Actually, I want to bring this really basic loop into our game loop function. Okay. All right. Cool. Okay. So if we want to actually get into that game loop, we need to now make an engine. Okay. So, what happened? We don't have access to the engine type because while we have created a new class, we haven't included that header file yet. So we need to include, okay, and we're going to start searching for header, we don't see anything. Actually, no. Yes, I am tired, aren't I? It's getting toward the end of the day. Engine.h, okay, so good stuff. Player position, I think, is something we're actually going to need to deal with in a sec. But we can create an engine. It's our engine, and when we can go engine.gameloop to get into it, all right? When we look within our engine, we're going to see a little bit of chaos. Okay, our functions are going a little bit crazy, but really quickly, let's hook up our input function, our update function, and our render function. Okay, get rid of the comments here because the code is so clear, we don't need them. And that's pretty much textbook right here. The functions, though, are kind of revolting. We don't have our symbols for cout or string. We can add them up at the top here. Let's go iostream, and let's go string, okay? So we've gotten rid of some of those errors. By the way, all this code you'll be able to download from the agenda, the lecture agenda, if you want it later. Okay, you don't need to take notes now. User input, what's up with that? Okay, user input, this is a variable we used to have just hanging out in main or in, where was it? Where did we put it? Where'd it go? Is that nowhere? Oh, it's gone now. Okay. User input is it's right here. Okay. And that's obviously not going to work. We need user input to be available outside of this function, but inside the engine. Okay. So here's what we're going to do. We're going to take this variable and we're actually going to move it into our engine. We're going to make it a private variable here. Okay. And now I believe it should be available. I think we can even, give it an initial value too, can't we? Yep. And so now we can actually use user input everywhere. We don't really have that problem. It's resolving now. Player position is another variable that we really do want to be available to, for instance, the render function and the update function. And so we're going to go grab that value, which is hanging out still in the main.cpp file. Let's go ahead and we're going to put it right here. There we go. Okay, so let's see if it's all resolving now. And it is. The only thing not resolving is running. Is running is in the game loop, so that's another variable, another piece of state we may want to move into our engine. Okay, so let's see here. And now that we've moved a ton of stuff around, we did a ton of changes So it's really important that we go ahead and run this. We run into an error, so we're going to look up what the error is. String is not a member of std, okay? And that definitely is, but what we haven't done is that in this H file, we haven't included string. So it seems like it's getting a bit confused about what string means. Okay, so we'll bring it in like that. Any other data types we need? Okay. And hey, there we go. We can go east, east, west, 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 east, east, quit, and it works, okay? And the code base is looking a little bit nicer. People can easily find where our code base begins. We can look at the engine class to see what all the core functions in our game engine are, and we can even see what kind of data it's holding too. Now note, this is actually gameplay-related data, right? And that makes sense because we're making a game. But eventually, in our engines, in a number of weeks, we're going to want to move all of our gameplay-related logic out of our engine and into Lua, into our scripting language, okay? Because we could have a game where there is no such thing as a player position, all right? That shouldn't be fundamental to our engine, but this week it is fundamental to our game, okay? Anyway, we've got about 4 minutes left, so one thing I'd like to try here is I would like to, and then I'll take some questions, I would like to see if we can include GLM, okay? Getting GLM included in the project is, yeah, I mean, anytime you're dealing with the compiler, you know, you're potentially in for some pain. So let's go ahead and extract this folder first thing, okay? Gonna extract this folder. Oh, it's taking a while. So GLM is a header-only library, which means it's nothing but .h files in there, okay? And those files, right, aren't going to be something that you have to link against. You're just going to be pulling all that code in to your source files when you build them, okay? And that should happen automatically if the preprocessor can find those files. Now, this is really nice because it's usually easier to get stuff working if you don't have to deal with linking and getting your binaries to the right place and libraries, all that stuff. But one thing that can be tough is if you, if it can make your compile times a bit longer, actually, because you do need to compile that extra code. It's not pre-compiled. You don't have to just, you can't just link with it. So I got this code. I've got it copied now, that folder. I want to go and I want to go find my project. Here's where my project is. There, that's where the game-engine-demo.sln is. In your engines, that needs to be game_engine.sln. And this is where Nikhil would usually create a third-party folder. I'm going to not do that. Going to be a little bit messy, okay? I really should put these two files, these .cpp files, into a source folder. Actually, I'm going to do that because that's a really good habit. I'm going to call the source, okay? I'm going to move my files into that folder, and my IDE is going to freak out, okay? It's going to pretend, if I try and build right now, it's going to pretend it lost everything. So what I'm going to do is I'm going to remove all these files. Don't delete them, but remove them. And then what I'm going to do is I'm going to go and I'm going to drag those files back in so that Visual Studio will now understand where they are, okay? And that's an annoying process for sure. Let's go ahead and make it run just to make sure that everything's building in. That's good. It's building. Now what I want to do is I want to include, what is it? It's going to be GLM. And look at that. It doesn't find it. It doesn't find it when I start typing. And that's because it's not looking in the right place, okay? I think I put it, where did I put it again? I put it, yep, it's right there. It's got that little 3 on the end. That's awful. Okay, but we'll make it work. We need to go tell our project. We need to tell Visual Studio where to look for our includes in this project. Go to Properties, VC++ Directories, go to Include Directories. That sounds about right. And now what I can do is I can write, hey, wherever my project's at, okay, project dir, okay, look into this GLM 09983 folder, okay? Just look in there, please. You can actually see at the bottom, right here, in the bottom half, this is where it's going to look. It's going to look at all these places. So if that looks right, like a valid path to you, then you might be okay, all right? And I'm going to click Apply, and then I'm going to go back. I'm going to try and type again, see if it has any more success. Oh, GLM shows up now. look at that. Oh, there's another GLM. I don't think that's what we want. Okay, so I think we want just GLM and then glm.hpp or something like that. So what I'm going to do here is I'm going to go in and I'm basically going to get rid of a level here. I think we want this one. Is that right? Yeah, that's it, isn't it?
Yeah, you just want to.
Yeah, the inner one, it looks like. And you see how this could pretty easily get messed up, you know? I'm going to pull that one right out. Let's see here. I might have to adjust my path because I don't think it's going to find it now. Yeah, it's not. I'm going to adjust my path one more time, and this one is really easy. I'm just going to say, you know what? Just look in my project directory, okay? Just do it. Just look in my project directory, and you should find it, okay? Now when I start typing GLM and then what else we got? glm.hpp, bingo, okay? It resolves, and now hopefully I can get access to types such as GLM IVEC. And there we go, IVEC2, okay? Player position 2D, let's call it. And I think I can do something, can I do something like 10.5 for X? Can I do that? No, nice, that's cool, okay? And if it builds, there we go. All right. So it's very easy to lose tons of time to all the small stuff, right? All the small stuff getting in our way, kind of nasty. But if you kind of know what the problem is, you can resolve these issues really quickly and you can get back to doing really interesting stuff, okay? We're 1 minute past time. I really wish you best of luck on this first assignment. I hope you enjoy it as much as the student at 2 a.m. last night telling me that they enjoyed it via Google Doc chat. I'm going to be here for 2 hours. Let me know if you have any problems. Hopefully we can get you all building very soon, okay? This assignment is not too bad, but don't sleep on it, okay? Get going, all right? Good luck. All right, everyone on the Twitch stream, thank you for coming, and we'll see you next time, all right? Take care, everyone. Bye-bye.